right, so a whole bunch of quick announcements. Number one, you guys all should have received 2 emails from me yesterday.
Yeah.
Okay. One of them is on rate functions. That's the one that we're doing tomorrow, so that's the one that you have to watch tonight. I was just trying to push ahead on the videos. And then the next one is on integration skills. That's the one you're going to watch tomorrow night. So make sure that you've got both of those. For those of you seeking some lunch support, I'm not sure if I'm going to be available. I have a conference call that goes till 12 and then another one from 12 to 1. But that one might end early. If you want to stop by and you need a place to stay, a place to watch some videos, if you have some questions for me, feel free to come by. I just don't know that I'll be available. I need you guys all to take out your orange cards because remember, I did not get a chance to do the participation signature at the end of class. I want to make sure everybody gets that. And also, if you attended any of the AP summits and did not get a signature from me, make sure I get it by the end of today. This is the last time I'm offering up signatures for the AP summits. There are no more AP summits. There are, however, 2, count them, 2 Saturday tutorials coming up, both here at Southwest. They're going to be this Saturday from 10 to 12, next Saturday from 10 to 12. They're already on the card because I planned these out a couple of weeks ago. And for anybody that comes to both, your lowest 2 progress monitors get dropped. Everybody okay? I'm automatically dropping the lowest one, but coming this Saturday and next Saturday gives you the opportunity for a second one to get dropped. This Saturday we're going to focus on multiple choice. It is going to be a whole lot of like your work time. We'll rotate through stations. You'll work with a lot of different students. Next Saturday it'll be free response that we focus on, and that's the Saturday before the common assessment, the AP exam. And this is for Southwest students only, unless you are dating somebody from another campus who happens to be taking AP Calculus. If you want to bring a loved one on Saturday, feel free, but I'm not throwing the doors wide open and saying the world can come to Southwest. This is VIP only, and you know your significant other. All right, I need to know on Friday though how many of you guys are going to be coming, and there's one homework assignment I need to collect and one that I need to check. The one that I need to collect is the progress monitor corrections that you started in class on Friday and finished this weekend. So put those in the middle of the table. All right. And if I can get everybody over to page 31, please. Why, hello. He just got here. Okay, apparently you're going home. Bye-bye. All right, so here's what I need you to do. On page 31, I know we already did this before. Yep, you can go. We would have already done this before. You guys had some time to do that scavenger hunt in the survival guide. You went around, you were in groups of 3. You looked up the various theorems, but I can see, for example, that Jose doesn't have the second fundamental theorem of calculus. Take this time, make sure you have all of them. Everything is located in your survival guide. If you don't know how to find something, go to the index. Everything is listed in the index. If you already have everything, like Roberto already has everything, if you want to use this time to make some flashcards, that would be a good thing. If you just want to spend time reviewing your notes, making sure that you know what's going on, even better would be to test yourself, cover it up and say like, what's the fundamental theorem of calculus? Do you know the fundamental theorem of calculus? And you get 8 minutes while I pass out papers, come around and do signatures, all the things. Folks watching the video at home, you might just want to fast forward about 8 minutes because there's not going to be much instructionally happening right now. Naomi, here you go. Ashley, Jose, here you go. Minos is gone. Carlos. Evelyn is not here. Jackie is not here. Kaylin. Here you go. Jesus. Beto. Pedro, we're not Pedro. Pedro's here. Roberto, here you go. Eric, here you go. Delia. Juan. Abraham. Delia. How do you Section 10. All right, orange cards. Signing for participation on Friday and see notes from the video this weekend. From today. All right, gentlemen, orange cards. All right, can we get notes? Probably named Theorems done. So it's that plus. Okay. Okay. And Jose, notes. Compare to the notes. Awesome. Are you doing the notes? It's still working well? Okay. It is not a total pain to do the videos. It's worth it. I know it's worth it, but I have to remind myself that it's worth it every single time. And last night, after filming the one you guys are going to watch tonight, I posted it. And then I realized that it has a soundtrack.
Yeah, I was playing music.
Hopefully it's not so loud that you can't still follow along, but I posted it after like filming for 33 minutes and I was like, why am I hearing music in the background? And I was like, I had my headphones plugged in while I was filming and I didn't hear the music from my laptop, but of course my laptop heard the music from the laptop. No, it's me, it's me. And my wife was horrified because sometimes I listen to really hard, and other times it's like gospel, like make you feel good about yourself music, and then other times it's like let the bodies hit the floor.
Y que él quiso para abajo, que se cayó. Y dice el maestro, ¿estás bien? Digo, no, no te preocupes, no te preocupes, que está bien avergonzado.
Do you know what that means? Tell me what it means. They don't know what it means. What is
Te volvió a parar.
Se cayó. Oh,
All
Bro, you told me you did the second derivative.
Hi.
I didn't check yours. Mi pantalón se ve bien, pantalón no va.
No, con el mismo pelito.
No.
Okay, the four theorems I am most interested in your knowing and knowing very well: the IVT, the EVT, the MVT, and the FTC, or the fundamental theorem of calculus. Everything we're going to do today basically is about all four of these. The IVT, what's the condition that you need for the IVT? You've got it on the notes in front of you. What's the condition? What has to be true to use the IVT? Okay, continuous on a closed interval. So over here is like the condition. And then over here you could say it's like the promise, like what do you get? Ah, you are here. Okay, if you have a function that is continuous on a closed interval, maybe you're thinking something like this. If this is the point A comma f of A, and here's the point B comma f of B, then if I pick some value, call it m, that's in between these two, the graph has to intersect that line at least once. Everybody okay with the IVT? Okay, so the IVT, when I see that the question is asking about like function values or possibly roots, that's when I'm going to use the IVT. The EVT, the conditions are the same. The EVT, this is that extreme value theorem. The conditions that I need for the EVT, continuous on a closed interval, A comma B. What do you promise?
Absolute max after something.
Absolute max and absolute min. Okay, so absolute max and an absolute min. That's just it. Now, where do the absolute max and the absolute min occur? They either occur at your endpoints or they occur somewhere in between. We can turn that off. Depending on what your graph looks like, you might say, okay, well, what about this guy here? Where's the absolute maximum? Where's the absolute maximum? The absolute maximum is going to be right over here, which is also a relative maximum. But an absolute minimum, where? Bottom left is going to be the absolute minimum. But what if I change the graph? What if I, not the graph, but the interval, and now I say, look on that interval. Where's the absolute max? The exact same spot. Where's the absolute min? The bottom right is now the absolute min. Could I ever change the interval so that the relative max isn't the absolute max? Is there any way to change the interval and get an absolute max that's not the relative max? Jackie, what could you do? Oh, I thought you were nodding along like, oh, you get this. How do you change the interval so that your absolute max is not the relative max? What could you do for that exact same piece of the function that we see? Naomi, what could you do?
So you could start from like the left point of the function and like stop somewhere around the y-axis.
Okay. If we go from there to there, where's the absolute max? The absolute max is over here on the right. Is that absolute max or relative max? No, absolute max, relative max, these things are different. Okay? All right, then we've got the MVT. The MVT, you still need continuity. You need continuity for all of these things. And then you need differentiability on the open interval. And that's the one, like the graph I would want you to have in mind. It's going to look something like this. You have some graph. You pick a point. You've got another endpoint. You find the slope of the secant line. And what is the slope of your secant is f of b minus f of a over b minus a. What does the MVT promise you? You guys have it in your notes. What does the MVT promise you?
F prime C
Something about f prime of c.
equals F of B minus F of A
F of b minus f of a
over B minus A.
over b minus a. F of b minus f of a over b minus a is slope of the secant line. F prime of c, you're saying that's a place where your tangent line has the same slope. So I'm going to think about the MVT when it asks about values for the derivative. That's what I'm looking for. If you're asking me things like f prime has to have a particular value, that's when I'm going to think about the MVT. Yep, she's here. Do you need her?
Yeah, she's good.
Okay, we get a lot of that going on today. All right, last one, fundamental theorem of calculus. Fundamental theorem of calculus, that's the one where it says that f of b is equal to f of a plus the integral from a to b of f prime of x dx. No idea what's going on with the seniors this morning. Hope you guys are all okay. Okay, that's your fundamental theorem of calculus. I want to do one problem with you guys together, and then you're going to get some time to work and practice, and then we're going to do a short assessment at the end of class. Okay, so if you guys could go on over to page 32, I want to look at question number 2. Those of you that watched the video, you already did problem number 1. Juan, we're flipping over to page 32. Let g be a continuous function on the closed interval -1 less than or equal to x less than or equal to 3. G of -1 is -10. G of 3 is equal to 6. Which of the following has to be guaranteed? Questions like this tend to be the lowest scoring for AP Calculus students. This is just where things fall apart for a lot of folks. Right? You're not given a graph. You're not given an equation. You don't have a lot of stuff to go off of. If they asked you to find the derivative, everybody would know what to do. So here's what how I'd recommend starting. When they talk to you about G, what have they told you? What has to be true about G? It's what? G is continuous on the closed interval from -1 to 3. So no matter what G looks like, it has to be continuous on the closed interval. Do we know what G looks like?
No.
G could be anything, but it has to be continuous on the closed interval. So what theorems do we get to use here? Continuous on the closed interval. You get to use which ones? The IVT for sure has to be true. The EVT, the IVT talks about like specific function values. The EVT is about like highest points and lowest points. Do we get to use the MVT?
No, that's differentiable.
You don't know if the function's differentiable or not, so the MVT doesn't work. It's not going to apply here. Now, which of the following are guaranteed? Guaranteed means like must be true. Which has to be true? Well, they gave me some points. They said G of -1 is -10. So here's the point, -1, -10. They said that G of 3 is 6. There's the point 3, 6. If you need a sketch of a function, sure. Could the graph look like that? It could. Does it have to? No. So give yourself some other graphs. Think of some crazy ways that you could get from here to here. Could the graph maybe do something like that?
Yes.
Could your graph do something like that? Could your graph do that?
No.
Yes, that's meant to be a cusp point. Is this possible?
Yes.
Some people are saying yes, a whole lot of folks are saying no because we don't like cusp points. What do we know about the function?
Continuous.
It's continuous. There's nothing said about differentiability. Could the graph look like this last one? Absolutely. This graph is not differentiable, but I was never told anything about differentiability. Pretty good? I just want to get some like crazy examples here. And now let's look. What has to be true? Does g of 0 have to be 0? Do they have to pass through the origin? Yeah, get that one out of there. B, g prime of c. Oh, derivatives. We're talking about derivatives. Does the derivative have to equal 0 somewhere in this interval? Does the derivative have to be equal to 0? Because you don't have the MVT at your disposal, you should not be having any conversations or any thoughts about the derivative. Because you can't use the MVT, there's no promise. If the derivative is equal to 0, you have a horizontal tangent line. Okay, you're not promised that. Does the derivative have to equal 4 somewhere?
Yeah.
No.
Yes, it does.
What's so important about 4 here?
Because we go from -10 to 6, and a value in between is 4.
Hold on though, I'm looking at C.
Oh, okay. No.
Last class, a lot of folks focused on the fact that if you find the slope, 6 minus -10 over 3 minus -1, you get 16 over 4, which is 4. They found the slope and said, oh, well, the derivative has to be equal to 4 somewhere. That's only true if what? If the MVT applies, but the MVT doesn't apply, so don't think about slopes. So it's not going to be C. Does g of c have to equal 4 somewhere? Right, that's the one because it's a value between -10 and 6. This one has to be true. Now part E, -10 is less than or equal to g of x, less than or equal to 6. These are your y values. We're saying that your y values are trapped between -10 and 6 all the time. Right? Here's 6, here's -10. Do the y values have to be trapped in between them? No, you could go up above, you could go down below. That's why it's not going to be this one. Some advice. Make sure you understand the conditions. Think about what theorems you get access to, and then maybe like give yourself a little bit of a sketch so you can go from there. All right, you guys have the next 20 minutes to work in your groups. We've got the cups out. Whoever got the most sleep last night, you are in control of the cups. Okay. What I want you to do though, number 2, I want you to skip for a little bit. I want you to make some progress. Number 2 is really tricky, and we'll talk about number 2 in about 15 minutes or so. So who's in control of the cups? You look like you got more sleep than she did. Alright, Benjo, who's in control of the cups of your group? You are? And Ashley, who's in control of your cups? Okay. And Juan, who's in control of your cups over there? Jesus, okay. Start at number 1, but I want you to skip number 2 for a little bit. Alright, we got the corrections. Corrections. You want Karen Friday?
So you know, I read, right?
See yours and Jesus?
Yes.
You did both of them?
No, like, you handed me this time.
I guess C could be the one.
2, 3.
2, 3. Function A just moves it down close to -2, 5. So it's continuous and differential.
So we know G, okay, what you be and oh, there it is. And then G of 3.
B is right. This is B minus exponential such that
Number 3.
F-
See, why no?
Yeah.
I think and then 2 that we true to the differential. You have to be the derivative is
I know. There's some C in the interval,
Zero.
So whenever I read anything about derivative has a value, I think about the mean value. That is the only one that we have that talks about derivatives. And with the mean value theorem, before you like make a decision, you go, oh good, it's good. If you're thinking mean value theorem, do you have continuity and differential? In this case, we do, right? So the promise is that the slope of the secant, if I find the slope that connects the endpoints, there's going to be a place somewhere in the interval where the derivative has that same value. So if I'm thinking MVT and I've got the conditions, my first move is go find that slope. Find the slope between the endpoints, and then I think you're going to start making some connections here. What did you guys pick? E. I feel pretty good about that choice. This question's a lot like the one that I just modeled for differences. Now you have the differentiability that you need. But you have questions like this with always just point, it's all sorts of points because you're like, I don't have a graph. I don't. What do you mean it could or it couldn't? Give yourself a graph and plot some points.
Yeah.
Okay, let's
So
go
it has to
ahead.
equal, wait, okay, yeah, you're right, I see what you mean, No, wait, but then, yeah, you're right.
You
Yeah, I'll
guys
get
made a decision
yes.
over there too.
I would say
Why?
The y of
Okay. So
the y
we know
of
three is, we know 3 is true because G is a continuous function.
Yeah.
So therefore, from -10 to 6, you have a problem.
So that is the inner right? It says that G is equal to 4 at some point. That's an IVT kind of question. See? So you've got a y value down here at -10 and another one up here positive 6. Does the function have to be equal to 4 somewhere in between? Right. Now what if I changed it? I said there's a y value down here at -2 and another y value up here at positive 1. It does now. Could the function be equal to 4?
Yes. Yeah, but it wouldn't be.
But the thing is,
We're not gonna.
could it be equal to 4? Sure, the function could go like, up above my arm. Does it have to be greater than 4? Does it have to be a place where you get to 4? No, you might just live in between these boundaries and never get up higher than 1. So that's the thing, you want to make sure that the y value is in between the two y values that you
There's this
have.
is the
Yep.
Number 3.
There exists a c on the interval such that f prime of c is equal to 0. Okay, and there exists a c in the interval such that f of c is less than or equal to f of x for all values of x. Okay, so you said D could never be false?
Who, me?
Okay, then I want to really emphasize could be false. Could D ever be false?
Yeah. The one?
Oh.
Right, you've got f of negative 2 is equal to 3, f of 5 is equal to negative 11. You have a point up here and a point down here. Does it have to be true that the function is equal to 0 at some point? It must be true, which means it could never be false. So that's why we put D. If you actually find the slope, which you did, I know that the value of the slope connecting the 2 points is negative 2. So there has to be a place where the derivative is equal to negative 2. So that's why you're not going to choose D or E. C, there exists a C on this interval such that f of C is less than or equal to f of x for all values of x in the input interval. This notation here says that there's going to be some place that is less than or equal to all the other y values. That's a clever way to say there's a lowest point. Does there have to be a lowest point? Why? EVT says that there's always going to be a highest point, so there's a lowest point. So C can't. A could be false because even though we're talking about the derivative, we're not talking about the derivative being equal to the slope between these two. You're saying the derivative equal to some random number. Good, keep going. So what have you guys do for?
We know it's A, but we just didn't know how to.
Oh, what number?
Oh,
These are okay.
Okay.
for this one, we know
They're like
the
two
answer
over
is
here,
A, but we didn't know how
but
to.
then they put you over here.
Okay, so I think the challenge that a lot of folks are running into with part C is not understanding this part here. There exists a C in this interval such that f of C is less than or equal to f of x for all x in the open limit. Sorry, if f of C is less than or equal to f of x for all values of x, that means that this C value is the smallest number on the interval.
Could be false now.
Does there have to be a place where f of C is smaller than everything else? What that is, that's the extreme value theorem. This is just a clever way to say absolute minimum, but f of C is less than or equal to all the other y values.
So the rest of them have to be guaranteed.
Yeah, the rest of them are good.
100%. So why doesn't G?
1 over 2, yeah, keep going. Yeah, number 2 is the one I asked you.
So they could
Show me how it was
Oh no, it's not that what it has to do.
Don't agree.
But this is going to have a horizontal tension line, so it goes like that.
Reduce
like
the-
that little thing right here. Yeah. That's what that is wrong.
Why is 3 wrong?
The function goes from negative 1 to 3.
We're going from negative 1 to 3.
It doesn't have to equal 4.
But here's the thing, you need to look not just at the x values, but then you need to look at the y values. G of negative 1 is negative 10. G of 3 is positive 6. If I plotted those points, it'd be like a point down here and a point up here.
If you lose it.
I'm down here at negative 1, negative 10, and up here at 3, 6. Does there have to be a place where the y value is equal to 4? There must be. So statement greater than past. That's your idea. Now, does the looking at statement number 2, does there have to be a place where the derivative?
Fundamental thermodynamics. This is branch goes to the MPT to
In this case, you get a function that's and at the same time, which means you can use the So if you find the slope of the secant line that connects these 2 points, what is the mean value there?
Explain to me. Why?
if the MPT applies and you get the derivative, the slope of this,
The slope of the secant line.
it'll have to equal that. The derivative has to equal that. So
The derivative has to be equal 4, because 4 is.
Oh, what's about?
Statement number 1 says the derivative has to the slope that
And he went to higher stakes.
so we're not going to have any promises.
Now we go back to 2. Yeah, no, we go back to 4. Or does it look like 2?
No, I'm going to see. So I don't know if I said 7.
Oh, yeah, it's
Okay, so if all goes well, number 1, you've got, I believe it's E, and number 3, you've got A. Keep going, look at 4, 5, 6, and 7. These are different kinds of skills that are being assessed, but still named theorems. Yes, sir.
What was the theorem of Theorem?
Right. Sorry for you.
I can take my 2.
Number 1. Yes. Okay, moving on.
Anyway, the graph of
Normally you start here.
go backwards, cut.
Yeah.
Okay, so
It depends whether they show you.
f of 3 are not defined. Right, to define what f of 0 and big F of 0. They give it big F of 0. So the graph is f. You got the graph. Right here. Every day. Wait, you did point this up, right?
There. There.
Oh, yeah. There, right there. Oh, it's a second. Wait, second first. If f is continuous, then on AB, then there is always another little line.
How are we doing? Okay, what are your grades? Other than the fact that it says on the they give you 1 point, they ask you for a different point, and the graph you have is about the derivative. That's why you're going to see it.
Making me
Alrighty, friends. Okay, I want to pull everybody together. If all went well, for number 1, you have E, and for number 3, you have A. If you made it past that, number 4, I'll just tell you what the answers are so you can jot these down. Number 4 is going to be B. Number 5 is going to be C. Number 6, my 6 and 7 I think are a little different from your 6 and 7. Okay, number 6 is C. And number 7 is C. Okay, we have a little bit of time. I want to look at number 2. You can take a minute on your own. Give it a read through. Number 2 is tough. Function f is continuous and nonlinear for -3 less than or equal to x less than or equal to 7. F of -3 is 5. F of 7 is -5. If there is no value of c with -3 less than c less than 7, for which f prime of c is -1, which of the following must be true? Okay. Important things. Your function's continuous. Do we know anything else about this function? Non-linear just means not a line, right? Not a straight line. It's got a curve of some sort to it. we've got these points, f of negative 3 is equal to 5 and f of 7 is negative 5. So maybe right now I'm thinking, okay, f of negative 3 is 5, so I've got this point here. F of 7 is negative 5. I've got that point there. Could my graph look like that? No, it can't because it's not a line. Could my graph look like that?
Yes.
Absolutely. Could the graph do that?
Yes.
Good. Could the graph do that?
Yes.
There's nothing in there about differentiability, so I want to keep thinking about the cusp point example. Furthermore, we know that f prime of c can't ever be equal to negative 1. Okay. So now we got to go through which of these has to be true. For some value of k, where negative 3 is less than k is less than 7, the derivative is less than negative 1. The next one, for some value of k, the derivative is greater than negative 1. The derivative is equal to 0. The derivative exists. The derivative doesn't exist. All of these questions are derivative questions. What theorem should you be thinking about right now? MVT. They're all derivative questions, so I'm thinking right now, MVT. They didn't say the function's differentiable, but they said that the derivative can't be equal to negative 1. Anybody see the significance of negative 1? What's so special about negative 1? They're asking about the derivative. They're asking all these things about negative 1. Why are they focusing in on negative 1? I was hoping the derivative would be the clue. Find the slope. Find the slope of the secant line connecting these 2 points. If I connect these two with a secant, I'm not saying that the graph is a straight line, but if you find the slope, what's that slope? The slope is 5 minus negative 5 over negative 3 minus 7. So that's 10 over negative 10, which is negative 1. The significance of the negative 1 is that that's the slope of the secant line. We're okay? But they're telling us that there is no place where the derivative is going to be equal to negative 1. The mean value theorem would say if your function is continuous and differentiable, then the tangent line has to be equal to negative 1 somewhere. Are we okay? So then make sure you get this in your notes. If f is continuous and differentiable, the mean value theorem applies, which would tell us that f prime of x equals negative 1 at least once. That's what your MVT says. If your function is continuous and differentiable, then your mean value theorem has to apply. But if the mean value theorem applies, the derivative has to be equal to negative 1 at least once. What do we know about the derivative? The derivative can't be equal to negative 1. If the derivative can't be equal to negative 1, what does that tell you? I want to be careful. If the derivative can't be equal to negative 1, then it tells me something about the mean value theorem. The mean value theorem does not apply. Well, why wouldn't the mean value theorem apply? Because the function's not continuous. Because you're not differentiable. You were told in the beginning that you have to be continuous. You have differentiability, it's this piece. So not differentiable. And if I ask you, hey, what are some reasons why a function's not differentiable? A cusp point, that's one reason. There's another. A cusp point is one reason why you would say not differentiable. The other one? Is it, wait, a what? Not a vertical asymptote. A vertical tangent line. You actually have a graph, but the tangent line is vertical. So you have a cusp point, or you have a vertical tangent line. Now for the person that said vertical asymptote, you can't have a vertical asymptote because you have to be continuous. So it's either a cusp point or a vertical tangent line. That's what has to be true. So look at the options. A, for some value of k, the derivative is less than -1. That's not it. For some value of k, the derivative is greater than -1. That's not it. For some value of k, the derivative is equal to 0. That's not the issue. For -3 less than k less than 7, the derivative exists. The last one, for some value of k with -3 less than k less than 7, the derivative does not exist. Has to be the right answer. Because if someplace the derivative doesn't exist, you're not differentiable, the MVT doesn't apply, derivative isn't equal to -1. This is a beast of a question. You should panic a little bit whenever you see this Master Math Mentor. The guy's name is Stu Schwartz, and he writes some vicious questions that are harder than the college work. Okay, we got about 5 minutes left. We're not going to do the assessment. Instead, I want you to take out your data sheet that I delivered earlier. And, okay, homework tonight is all about rate functions. And you get a little soundtrack with it, apparently. All right, you're going to want at least one marker, probably 2 here. So for all 330 calculus students in the system, everybody's got a letter that looks something like this. What I did is I went through and I looked at common assessment results for every single kid in the S-Prep system. And what you see at the top is a summary of the 6 free response questions. Each free response question is worth 9 points. How many of y'all found at least one question where you're earning like 4 points or more? You've got at least one question. How many of you guys have at least one question where you're getting 0 points? At least one question, or maybe you got a point. Everybody seems to be in both places. Most folks have at least one question where you did pretty well, and at least one question where you didn't do so well, and a lot of you actually have a couple of questions where you didn't do quite so well. That was 2 weeks ago, before we started doing the progress monitors, before we did all the review. I would assume that if I gave you all 6 questions now, your score already would go up because of the work that you're doing. Okay? Look at the next piece, and this is where I want to give you guys some time to process. I then went through and I said, let me look at the multiple choice and the free response. In total, the AP exam has 108 points. Every multiple choice is worth 1.2 points. Every time you get one right, even if it's a guess, 1.2 points. Every free response is worth 9 points. Look at the 10 topics. All 10 topics, these are the ones that get assessed every single year. Some of these are more heavily assessed than others, meaning they're more important than others. The good news is, because I've been pushing you guys so hard since August, we actually have enough time that we're going to spend at least 1 day or more on every single one of the topics. There's nothing that we're going to skip. There's nothing that we're going to leave out. What are some high-value topics? Look at the number of points possible. Derivatives. Where is that?
Rate function.
Topic number 4 is derivatives. 14.6 points. That's 14.6 out of 108. That's a lot. That's like 13% of the points.
Topic 5.
Topic number 5, rate functions. 24 points out of 108. That's more than 20% of the exam is rate functions. Rate functions are huge. Remember all those in and out problems like the swimming pool, and we did the amusement park and all the Riemann sum stuff? That is huge. The system average was 6.7, 6 points out of 24, not very good. This particular person did really well. They got 11.4 points out of the 24. Any other high value places? Physics is huge. We're going to spend 2 separate days on physics, particle motion, because it's huge. It's always heavily assessed. Everybody good how to read this? Okay, then you've got your score, so you can see how you did. Whoever this person is, they did relatively well on rate functions. But I also want you to compare to the system average. And how did you do compared to the system? Are you beating the system average? Are you below the system average? So take a minute and I want you to identify 3 places where you know you need to focus. 3 places where you need to spend some more time and energy. You might want to compare your score to the system average and see where are you farthest away. Maybe you want to look for places where, like, wow, this is a high value place and I'm not earning as many points as I want to. Everybody get 1 or 2 places? All right, I want to close out with this last part. The table at the top, this is on the back, summarizes the results. Last year, 209 students earned a 1. This year, 157 earned a 1. So the number 1's decreased. The total number of students in the system has increased. So that's actually a really good sign. Now, sadly, only 2 people out of 330 got a 5. But that's okay, because that's the practice test. Last thing I want you to look at. Find your score. For this particular person, it's 37 points. And the average calculus student, the average calculus student at Southwest will grow their score by 20 points. 20 points is the average growth from the time you take the common assessment to the time that you take the actual AP exam. This year, some of the things to get beyond average are all those videos that you guys are watching. The AP summits that you've attended. Look at your score, add 20 points to this. Now look over here at the points earned. How many of you would be meeting or beating your goal if you picked up those 20 points? Most people are meeting or beating their goal with that average growth. If you're not meeting or beating with the average growth, you're going to have to dig in a little bit more. We'll keep talking about this tomorrow. Watch the video. Video tonight, 33 minutes, rate functions. You must bring your calculator.